Good morning to all the NEET aspirants. Here we welcome you for a crash course of NEET for 2020 aspirants. See, we all know you have board exams, but after finishing your board exams, merely you only have 1 month left in your hand. And in that particular 1 month, it is very difficult for a student to visualize that how should we complete the total 3 subjects and how should we organize these 3 subjects in a proper manner to get a full revision. So here Pathfinder presents you a very short term crash course of 15 hours for each subject. Myself, your chemistry teacher. So let us start with chemistry first. See, we have selected, our Pathfinder research team rather have selected few topics of each and every chapter, few subtopics rather of each and every chapter, which we think this year will be most vital. So it is very much essential that you must note down all these vital subtopics before getting into the act. Okay, so first of all, we will start with, we'll take 3 chapters at once, that is atomic structure, mole concept, and mole and stoichiometry 2. Okay, mole stoichiometry 1 and mole and stoichiometry 2. Mole and stoichiometry 2 means basically the redox reactions chapter. So let us start with atomic structure first. Achha, before getting into atomic structure, few questions of atomic structure which have come in the previous years or which we think is important, these types of questions, these pattern of questions, we have highlighted those questions in this model. So let us start with atomic structure. First of all, I will make you know that what are the main subtopics of atomic structure that you must know before starting. Okay, number 1, first of all, you must know the Bohr's atomic model. Bohr's atomic model. And from Bohr's atomic model, basically you might know the energy related formula, that is minus 13.6 into z square by n square electron volt. Okay, and from that portion we have seen for the past few years question have came. So in Bohr's atomic model, the energy calculation part is very important, and the next important part is the hydrogen spectrum, which is very important. Hydrogen spectrum is very important this year, and from hydrogen spectrum we all know that there is a formula that 1 by lambda equal to RH into z square into 1 by n1 square minus 1 by n2 square. When you will study the hydrogen spectrum, make a short note of all the series you have studied, that is Lyman series, Balmer series, and what is the first line of Lyman or what is the last line of Lyman. Okay, shorter wavelength, longer wavelength, you might note down in your one rough copy these short points before getting into the chapter. And after hydrogen spectrum, one of the most vital part is the quantum numbers. And in the quantum numbers, basically principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, there are various formulas. Which you must you must ensure that you must remember all the formulas when you are sitting at the exam hall, because you will have to carry a lot of formulas in your mind, which is at this stage sitting at the exam hall, it is merely impossible to remember all those formulas, but there are few formulas which are very vital. Like in quantum numbers, if we note down that angular momentum of an electron in an orbital, and we all know that angular momentum, what is the formula of angular momentum? And the formula of angular momentum in an orbital, root over L into L plus 1 into h by 2 pi, and sometimes we write this h by 2 pi as h cut like this. Okay, then one of the most important formula is the magnetic moment, and the unit of magnetic moment is Bohr magnetum. The first question given to you is based on the magnetic moment. Okay, root over n into n plus 2, and where n is basically the number of unpaired electrons. Okay, is it clear? So let us start with the first question as we have came to the magnetic moment part. So coming into the magnetic moment part, first of all, Here it is given that match the metal ions given in column 1 with column 2 with the spin magnetic moments of the ions given in the column 2. Okay. Acha. Now here it is given that we have to match the column 1 with the column 2 with their spin magnetic moments. Okay. So let us start with the spin magnetic moment first of CO plus 3. Now cobalt. Cobalt we all know it is 27. 27 means atomic number is 27 means after 3p6 there will be 4s2 and 4s2 means 20 and after that it will be 37, right? So after 4s2 it will be 37. So when we will eliminate the 3 electrons from cobalt, 2 electrons obviously will go from 4s2 and 1 electron will go from 3d7. So obviously 3d will become 6 in CO plus 3. 3d will become 6 and 3d6 means we all know. How do we draw 3d6? According to Hund's multiplicity rule, like this. So how many unpaired electrons are there? There are 4 unpaired electrons. So what will be the magnetic moment of cobalt? Magnetic moment of cobalt will be root over 4 into 4 plus 2. 4 plus 2 means 6. 6 into 4 means basically 24. So it will be root 24, right? So CO plus 3 is matching with this one. Okay. Now coming to Cr plus 3. Chromium. What is the electronic configuration of chromium? Chromium electronic configuration is 3d5 and 4s1. Now if I eliminate the 3 electrons, first electron will go out from S and the rest 2 will go out from D. So obviously it will be left with ultimately 3d3, right? Acha. Now let us tell you something that 3d3 means what will be the magnetic moment? It will be 3 into 3 plus 2, we all know, right? Okay. So if I do this 3 into 3 plus 2, it will be 5 into 3, that means root 15. So Cr plus 3 is basically matching with root 15. Now, so A will be cobalt, A will be 4. See, there are 2 options where A is matching with this 4, right? Okay. Now coming to the B. B is matching with 5. Is there any other option where B is matching with 5? This option is matching. But here, first one is not matching. So obviously, after solving these 2, we will be confident enough that obviously the first option will be our correct option. Is it okay, student? See, we have to save time. The most important part of the NEET exam is that you have to save time. If you try to solve all the questions at once, you will not be all the options at once, you will not be able to save time. So it is very important for you people so that you can save time of your own, so that you can crack NEET with a very good score. So let us come to the next question. Now see, these type of question have came in 2017. This type of question has come in 2017 NEET. Okay, where 114 atomic number and element is given and it is said that to which group or family or the electronic configuration it belongs. Fine, no problem, but this is a very time consuming type of question. We must know that. So to eliminate time, what should we do first? We must think about radon. What is the atomic number of radon? Now atomic number of radon is 86. Okay, so after 86 we can see that it will be 5f14. Obviously after 5f14, 86 plus 14 means 100 gone. After that it will be 6d10, so 110 gone. So after that it will be 7s2, obviously 6d10 tapori 7s2, it will be 7s2, and after 7s2 it will be 7p2, right? So obviously 112 plus 2, 114. See, these 3 options are not matching. So obviously the first option is the correct option. Is it clear? Okay, thank you students. Let's move on to number 3. Now see, I have told you that quantum number portion is very much highlighted in NEET UG. So we must know the quantum number portion very strongly so that we can solve each and every question within fraction of a second rather. So this is a very tricky kind of question which students makes a common mistake, that n is equal to 3, n is equal to 3, L is equal to 1 means we all know that it is P subshell, right? So obviously it will be 3P, okay? And seeing the 3P, whenever you will see P, Three boxes come to your mind, right? Yes or no? And we all know that 6 electrons can be filled up. Obviously your eyes will get lit up and you will mark this option, but it will be totally wrong, because here one of the main thing that is given in the question can fit in the orbital. Now what is orbital? Orbital means one room. Okay, so there are 3 rooms. Now in one room, how many electrons can be maximum fit? It will be obviously 2, not more than 2. So correct option will be option 2, that is 2 electrons can be maximum filled up in an orbit. Whatever may it be written in the question, n is equal to 4, l is equal to 2, or rather like this, but if it is said that orbital, always know that it will be only 2 electrons. Let's move on to the next question, students. See, it is also a very important part from the quantum number portion, because we all know that there are 5 d orbitals, right? There are 5 d orbitals, and what are the names of those d orbital? It is dxy, it is dyz, it is dzx, it is dx square minus y square, and it is dz square. Okay, now a very important thing you must note that these 3 orbitals lie not along the axis. Suppose this is y axis and this is suppose x axis. Okay, so if I draw this one like this will be our dxy. So the lobes don't lie on the axis, it lies between the axis. Only these two, dx square minus y square and dz square, you must know that dx square minus y square, the structure is like this. One lobe lying in the y axis, one lobe lying in the x axis. And not only this, so correct option will be dx square minus y square and dz square. And for dz square, this is the diagram. There is one lobe lying along the z-axis, and there is a circular ring like this which engulfs it. Okay, is it clear? So not only that, from this portion it is mandatory, what I am suggesting you is that also study how many nodal planes do they contain. It is a very important area for NEET also. Okay, see, we cannot discuss so much in details in this 15 hours crash course, but whatever we are saying, make it a note. It may so happen that we might not cover all the parts which are important, but we will definitely tell you that which part you need to study on your own, so that before getting into the exam hall, the 1 month which is left with you after the board exam, in that 1 month you can revise yourself so perfectly that ultimately you will be totally ready to sit for the NEET exam. Okay, so the correct option will be option 4, that is dz square and dx square minus y square. Let's move on to the next question, students. 2 electrons occupying the same orbital are distinguished by. Obviously, suppose there is a p orbital. Okay, right? Now I am starting to fill up electrons according to Hund's multiplicity rule. First it is filled up singly with the same spin, and then it is filled up with the opposite spin. Right? Achha. So in an orbital, the 2 electrons can only be distinguished by their spin, not by anything else. If one is plus half, other will be minus half, right? Okay, so it can only be distinguished by spin quantum number. Is it okay, students? Let's move on to the next question. Now, already I have told you, see, there is a question from hydrogen's atomic spectrum. It is given. Okay, and it is a very important question, because these type of questions is very much favorable for the NEET exams. Okay, so here it is told that, now see, this question you can solve it in many manner, but to save time, because your most precious friend from now on must be time, not anyone else, because you must know how to save time. Okay, as you save your friend, you must know how to save time also. So which transition in hydrogen atomic spectrum will have the same wavelength as the transition n is equal to 4 to n is equal to 2 for of He plus spectrum? Now it is being told that both of these transitions will have the same wavelength, and we know 1 by lambda is equal to what? RH. Now see, RH is a constant, which ultimately will be same for both. So ultimately, if I write the formula once first, 1 by lambda equal to r into z square into 1 by n1 square minus 1 by n2 square, right? Is it okay? So now by the problem, what I can do, I can equal these two possibilities, one for hydrogen spectrum and one for helium spectrum, because this term will be same for both. Whatever be lambda or 1 by lambda, it will be same, right? So ultimately, what we can do, we can write this. For hydrogen, Z is 1, we all know. So ultimately, it will be R will get cut off, but still I am writing it. R into 1 square, I am not writing it as 1 square. We don't know the transition for hydrogen spectrum, right? We have to find it out. So I am writing as N1 and N2. N2 is the orbit from which it is coming, and N1 is the orbit where it is coming. Okay, it should be equal to R into Z. For helium, what is Z? Z is 2. So it will be 2 square into ultimately 1 by, it is coming from N1, here will be 2. So it will be 2 square minus 1 by 4 square, right? Is it okay? Fine. R obviously will get cut off. It will be ultimately equal to 4 into 1 by 4 minus 1 by 16, right? Now, if I multiply this 4, it will be rather 1 by 1. How can I write 1? 1 whole square minus 1 by, it will be 4. How can I write 4? 2 square. So ultimately, see, it is just getting match with this pattern, 1 by n1 square minus 1 by n2 square, in this manner. So what must be the n1? 1. What must be the n2? 2. Okay. So our correct option will be 2 to 1. The transition will occur. Is it okay, students? Let's move on to the next question, please. Number of d electrons in Fe plus 2. See, these questions tests your mind, your skill, your speed or your accuracy sitting at the exam hall, because you have to face 180 questions in 180 minutes. That means each question will, for each question you will get just 1 minute time. If you can crack the question in less than 30 seconds, you can save hell lot of a time. So it is mandatory for all the students to know first of all how to save time. Okay, so again I am coming to the most precious thing, that is time. So now number of d electrons in Fe plus 2 is not equal to the number of electrons in which one of the following. Now clicking Fe plus, when you are seeing that Fe plus 2, that means Z equal to 26, you are seeing Z is equal to 26. Now 26 means obviously your mind will click that after 3p6, 4s2, 3d6. So when it is 4s2, 3d6, and when we will write Fe plus 2, what should we write? Obviously only 3d6, right? Only 3d6. So how many d electrons are there? 6 d electrons are there, obviously. So 6 d electrons. So for magnesium, number of s electrons. For magnesium, number of s electrons. For magnesium, it is 1s2. After that, 2s2. After that, 2p6. After that, 3s2, right? So how many total s electrons are there? 6. So it is matching. Very good. Now coming to the p electrons in chlorine. For chlorine, what should we write the configuration? 1s2, 2s2, 2p6, 3s2 and 3p5. Obviously we can see how many number of p electrons are there. 2p6, 3p5, that means 11. It is not matching. It is not matching. Okay, fine. So obviously we'll not move further, because here only one option can be correct. We'll just point it out. Wherever we will see the point of difference, we will mark it, and ultimately we'll move on to the next question. Let's move on to question number 8, students. The angular momentum, just now what I am saying, the angular momentum of electrons in d orbital. Angular momentum of electron means root over L into L plus 1 into h cut, because here it is given as h cut. Okay, so now for d, what is the value of L? Value of L is 2, so it will be 2 into 2 plus 1 into h cut. So it will be 3 into 2, that is root 6. So root 6 h cut, so option 1 will be correct. Is it okay, students? So it is very important for you to remember all the formulas when you are preparing yourself. So make a list of formulas in one of your copies and just revise every day for 1 hour those formulas. You will see after 30 days all the formulas will be stored in your brain. No formulas will go out from your brain. Okay, let's move on to the next question, students. Calculate the energy in joule corresponding to the light of wavelength 45 nanometer. Now, here it is a question of energy related, that is Planck's quantum theory. We all know a very famous formula which you use in many chapters of chemistry, that is E is equal to hc by lambda, right? Now over here we have to calculate the energy. The value of H is given as 6.63 into 10 to the power minus 34. C, we obviously know it is 3 into 10 to the power 8. It may be given, it may not be given, but you have to remember this. Okay, divided by, now what is lambda? Lambda is given here, C, in nanometer, but we can't keep it in nanometer because it is in meter. So we have to forward it into meter, right? So it will be 45 nanometer to meter into 10 to the power minus 9, right? Now if I arrange all the 10 to the power values, we will see that 10 to the power minus 34 into 10 to the power 8 means 10 to the power minus 26, and when this 10 to the power minus 9 goes above, ultimately it will be 10 to the power minus 17, right? Now, see, you have to save time. Again, I am saying that. So obviously, we can't take it as 6.6. We will just mentally calculate it as 6. And 6 into 3 means how much? 18. So now it remains with 18 by 45. It cuts with 9. That is 2. That is 5. So ultimately, it will be 0.4 into 10 to the power minus 17, right? So ultimately 0.4 means 4 by 10. So 10 will again go above. So it will be ultimately 4 point something. 4 point something into 10 to the power minus 18. Obviously it will be like that. So obviously, see, here we have eliminated the 6.63 kind of part. So obviously for that this value is coming. We have just kept it as 4 into 10 to the power minus 18. But obviously after 4, something will appear 4.42 like this. So obviously only in one question this sort of answer you can find. Only in one option you can find this sort of answer. So it's quite obvious that this one will be the correct option. Okay, let's move on to the next question, students. Acha, see, before we enter into the mole concepts, first of all let me tell you that from atomic structures, what we have picked up for this year. For this year we have picked up, first of all, say quantum number portion. See, one genuine question will come from quantum number part. Either it will be magnetic moment, or it will be angular momentum of an orbital, or it can be regarding electronic configuration, or it can be regarding shapes of orbitals, or it can be regarding nodal planes or like this. So obviously you must study all this. This portion is very vital. And apart from this portion, the portion of hydrogen spectrum, which is related to the Lyman-Balmer series and those all, it is very, very highly important. And other than that, obviously from Bohr's atomic model, you must take a look of each and every formula what you have studied in your class 11 part. Okay, so here we end. What are the important topics for atomics, important subtopics from atomic structure? Now we will head on or move on to the mole concept 1 and mole concept 2. See, there will be no theories in mole concept 1 or mole concept 2 which you have to study. You only have to remember few pattern of type or sums which will ultimately enrich you when you will go to the exam hall. So from mole 1 and mole 2 we will study few pattern of questions which are important, and obviously those questions will not come directly, but that pattern, if you have it in your mind, then only you can solve those kinds of questions. So very carefully take a close looks of what pattern of questions we have chosen from mole concept 1 and mole concept 2, that is the redox. Thank you, students. Let's move on to mole concept 1 and mole concept 2. We will discuss mole concept 1 as well as mole concept 2, that is redox. Now, before getting into the mole concept chapter, let us first formalize or say formulate few things in your mind, because in mole concept chapter actually you don't have to remember any kind of theory. There are some peculiar formulas, or there are some particular formulas which you keep in your mind. It will help you eventually to solve problem in quite lesser time. So I'm straight away going to the mole and stoichiometry 1, that is mole 1, few important formulas. Number one is percentage W by V, percentage W by V, weight of the solute by volume of solution in 100 ml solution, right? We all know the definition, we are not going into that, will be equal to percentage W by W into density. Is it okay? Now let's come to the second formula, that is molarity. Molarity. Now what I can say about molarity? Molarity, we can say that it is 10 into percentage W by W into D divided by molar mass of solute. Is it okay? Okay, right? So basically we know that what is molarity. We are not going into the definition, and we know also that molarity is equal to number of moles of solute divided by volume of solution in liter, right? But over here, if question is given in the form of percentage W by W or density, then directly we can apply this formula to solve the question. Now let us come to the next formula, that is there is a small relationship between molality and molarity. Molality is denoted by small letter m, we all know this is molality. It is equal to 1000 into capital M, that is molarity, by 1000 into D, that means density, minus molarity into molar mass of solute. Okay, so this is another formula which gives the relation between molality and molarity. Is it okay? Fine. Now let's come to another formula, that is molality related with mole fraction. Molality can also be written in the form that mole fraction of solute by mole fraction of solvent into 1000 by molar mass of solute. Is it okay? And apart from this, see, there are many other formulas. Those are basic, you have studied in class 10, that is what is number of moles or like that. I am not going into further deep into that formulas, but the main formulas which you have to keep in your mind to solve a question in fewer seconds is these formulas first of all. And after solving this and after formulating this, let us come to the mole concept 2. Mole concept 2. Mole concept 2. That is what we call it as redox reactions. Okay. So in redox reaction, see, we will just understand few things about redox. First of all, the main thing about redox is the N factor. It is very, very essential to understand what is N factor. Now we all know, I am not writing over here, we all know that for acid, basically N factor is equal to basicity. Basicity means number of H plus it releases, right? And for base, it is acidity, that is number of OH minus it ultimately releases. Okay. And if suppose any reaction is going on, and in that how many H plus is being replaced, that is also will be equal to the N factor of that particular compound. We all know these basic things, so we are not going into that. But let us come to the equivalent concept. Equivalent concept before getting into further detailing of N factor. Okay, equivalent concept. Now equivalent weight is basically equal to molecular weight divided by N factor. I am writing as a N factor as NF. Okay. Now we all know that number of moles. What is the formula for number of moles, dear students? It is given mass divided by molar mass. So for number of equivalents, what can be the formula? Number of equivalents equal to, basically it will be given mass by equivalent mass, right? By equivalent mass. Now in place of equivalent mass, what I can write? Molecular weight by N factor. So N factor will go up in the numerator side. So ultimately number of equivalents can be written as number of moles into N factor, because given mass by, in place of equivalent mass, what we have written? We have written molecular weight by N factor. N factor has gone up. So given mass by molecular weight, we all know that is the number of moles. So number of equivalents is basically equal to number of moles into N factor, or what I can say as number of milli equivalents can be equal to number of, it will be then millimoles into N factor, right? Number of millimoles into N factor. Now in place of number of millimoles, what I can write? Number of millimoles is basically equal to molarity into volume in ml into n factor. This is the formula for number of, say, what is milli equivalents. Is it okay? Fine. So this is the basic concept of equivalent weight, and in terms of normality we can say that equivalent weight can be written like this, that it is ultimately number of equivalents can also be written as normality into volume in liter, volume of solution in liter. So from here again what I can write is number of milli equivalents equal to, it will be normality into volume of solution, then it will be in ml, because from liter if I multiply it by 1000 it will become ml. Okay, fine. So these formulas we must keep in mind before solving any kind of problem. And now going to how to calculate n factor basically. Okay, n factor. So how to calculate n factor? For that we must know first that n factor of a redox compound. Now how to calculate n factor of a redox compound? Let us move to another page. So say if I am saying that KMnO4 is going into Mn plus 2, and this happens basically, it is occurring in acidic medium. We must know that, because sometimes in the question it will be written that in acidic medium, then we have to judge from KMnO4 what it can, where it can go, that is up to Mn plus 2 it can go. So here in KMnO4 it is plus 7, here it is plus 2. So basically it is the net electron lost or gained per stoichiometric coefficient of the compound. So how many electron over here from plus 7 to plus 2? It has gained 5 electrons. Obviously we can see. So here the n factor of this compound will be how much? 5. Is it okay? Fine. Now say if I tell you about SO2, it goes to SO4 2 minus. Okay, fine. From SO2 to SO4 2 minus, here sulfur exists as plus 4. Here in this compound sulfur exists as SO4 2 minus, it is plus 6. Okay, so what can be the n factor? It will be 2. Obviously n factor of SO2 will be 2, because net electron lost will be 2 electrons. Okay, now KMnO4 again, if I say if it goes to K2MnO4, if it goes to K2MnO4, in K2MnO4 it is plus 6, and here to obviously it is plus 7. This reaction occurs in alkaline medium, which we must remember. Okay, so ultimately from plus 7 to plus 6, what is the n factor of this compound will be? N factor will be 1. Now suppose if KMnO4 goes to MnO2, here Mn is plus 4, here Mn is plus 7, so ultimately here n factor will be how much? 3. Okay, and this occurs in where? Neutral medium, right? Okay, fine. So these are the few reactions in which how to calculate n factor. Now here only one atom is undergoing a change in oxidation state. Now suppose if two atoms undergoes change in oxidation state, how to calculate the n factor of that compound particularly? Suppose if I am telling you that As2S3, okay, it goes to As plus 5 and SO2, As plus 5 and SO2, right? Now in As2S3 we all know that sulfur is how much? Minus 2. So minus 2 into 3 means minus 6. Will not write minus 6, will write minus 2, because the oxidation state of each atom we always write in the in their top. So if it is minus 6, it must be plus 6. So here each As will be plus 3, and obviously in sulfur dioxide it will be plus 4 sulfur, because there are 2 oxygen, minus 2 into 2, that means minus 4, it must be plus 4. So here As ultimately is undergoing a change from plus 3 to plus 5. From plus 3 to plus 5, how much units? 2 units. For one As atom, 2 units. For 2 As atom, how much unit? 4 units in total. So ultimately we'll always remember that 4 loss is occurring. Okay, right. So now for sulfur, it is going from minus 2 to plus 4. Minus 2 to plus 4, the change is 6, right? Minus 2 to plus 4, change is 6. For one sulfur atom, 6 change. For 3 sulfur atoms, it will be 6 3s are 18 change. So net loss will be 18 loss of electrons. So total loss will be 22. So here the n factor will be 22 for this AS2S3 compound. Is it okay? I think we have done enough practice before going into the problem sets. One more thing that we must know, that is to calculate the equivalent weight of a disproportionation reaction. It is very, very important how to calculate the equivalent weight of a disproportionation reaction. Always remember, I am telling you a shortcut technique over here, that suppose Cl2, it goes to Cl minus plus ClO3 minus. Here in this compound Cl is plus 5 and here it is minus 1. Here Cl2, in Cl2 it is 0. From 0 to minus 1, how much change? 1 change. For 1 chlorine atom, 1 change. For 2 chlorine atoms, there will be obviously 2 change. But here, what is the process occurring over here? Reduction. Okay, it is gaining electrons. And from here to here, what is the process occurring? Oxidation, right? So, if I now want to calculate the N factor for this reaction, remember one simple thing. It will be N of oxidation, N factor of oxidation into N factor of reduction divided by N of oxidation plus N of reduction. Now just calculate. N of oxidation, how much? For 1 chlorine atom 1 change, for 2 chlorine atoms 2 change. So 2 for reduction, and how much for oxidation? It will be 10, because for 1 chlorine 5 change, for 2 chlorine 10 change, right? So it will be in the numerator, it will be how much? It will be 2 into 10, right? Divided by, it will be 2 plus 10. So ultimately it will be 20 divided by 12. Ultimately it will be how much? If I cancel it with 4, it will be 5 by 3. Now once we have find out the N factor, we all know that equivalent weight of this compound will be molecular weight divided by this N factor, that is 5 by 3. Is it okay? Fine. So here let's start first of all doing the problems, and then we will gradually move on. First we'll move on to mole 1 and then we'll gradually move on to mole 2. Is it okay, students? Let's move on to mole 1 problems. See, first question. The first question, this question is actually from the year, I think 2018, it came in NEET. Okay. In which case number of molecules of water is maximum. Now see, in first option it is given that 18 ml of water. Now 18 ml means how much gram? 1 ml means 1 gram. So 18 ml means how much gram? 18 gram. So 18 gram water means how many moles? We can calculate it mentally just because it is a molecular mass of water. So obviously it will be 1 mole, right? Now comes 0.18 gram of water. Now 0.18 gram basically means how many mole? First of all, 0.18 divided by 18, that means how many moles? Number of moles will be 0.18 divided by 18, it will be 0.01 moles, right? Achha. Then here 1 mole, here 0.01 mole, here to already it is given as 10 to the power minus 3 moles of water, and here it is given in terms of volume. So if I now try to find out in terms of mole over here, then what should I do over here? Number of moles will be basically 0.0024, 0.00224, basically 0.00224 divided by 22.4, right? 0.00224 divided by 22.4, it will nearly come as 10 to the power minus 4 mole, right? Okay. Now we have to calculate in which case number of molecules of water will be maximum. Now see, here it will be 1 into Na, here it will be 0.01 into Na, here it will be 10 to the power minus 3 into Na, here it will be 10 to the power minus 4 into Na. So we can clearly see that in this case number of molecules of water is maximum because it is only 1 Na. Okay. Is it clear, students? Let's move on to the next question. X and Y. These types of questions are very much probable in NEET. Okay. Because these are few stoichiometry related questions, and sitting at the exam hall we sometimes gets confused by looking at these questions, by solving this question, and I've seen many times that students do very silly mistakes in these kind of questions. Achha. Now suppose the elements X and Y combine to form two compounds XY2 and X3Y2. Okay. So when 0.1 mole of XY2 weighs 10 gram, 0.05 mole of X3Y2 weighs 9 gram, the atomic weights of X and Y, we have to find it out, right? Acha, first of all, let us take the example of xy2. Okay. Acha, for xy2, what is the number of moles given? We all know that number of moles is equal to given mass by molar mass, right? So, number of moles given for xy2 is 0.1. So, 0.1 equal to given mass. What is the given mass? Given mass is 10 gram divided by, what is the molecular mass? Molecular mass is, suppose I take the atomic weight of x as x and y as y. So, ultimately it will be x plus 2y, right? And from here we can clearly see, we can formulate a equation, that is x plus 2y will be equal to basically 100. So, this is our equation 1. Okay. Now, if I come for x3y2, now for this, number of moles given is 0.05. So, 0.05 will be equal to given mass 9 by molecular mass. Molecular mass will be 3x plus 2y. And from here, if I calculate 3x plus 2y, 3x plus 2y will be equal to 180. So, these are the two equations from where we have to solve just x and y. If you solve this, you will see that x will come as 40 and y will come as 30. Okay. So, which one will be the correct option? Option 2 will be the correct option. Okay. Let's move on to question number 12. Now, see, this is a question where percentage purity of the sample we have to find it out. Now, we know whenever magnesium carbonate is decomposing, it is forming CO2 plus MgO. We are not required with CO2 over here in this given question, because 8 gram of magnesium oxide is produced when 20 gram of magnesium carbonate sample decomposes. It is given like that. Now, normally what is the molar mass of MgCO3? If we calculate, then we will find that it is 84 gram and it will be how much? 40 gram. So, we can say like this, that 40 gram MgO, it is prepared from how much gram MgCO3 normally? 84 gram. So, basically here we have, in the question it is given that 8 gram magnesium oxide is being produced by how much gram? Let us find it out. So, it will be 84 by 40 into 8. Okay, fine. 84 by 40 into 8. How much it will be? If I cancel this, it will be 84 by 5. We can take it a look and see that obviously it is less than 20. Out of 20 gram magnesium carbonate, this much is the purity. This much is the purity. This gram is the purity. So, what is the percentage purity? Percentage purity will be, it will be 84 by 5, whatever gram it is coming. Okay. Okay. Divided by 20. That means it will be into 1 by 20 into 100. Right. Is it okay? Fine. So, 0, 0 will get cancelled. 5, it will be cancelled by 2, and here it will also 2 and 2 will get cancelled. Answer will be just 84%. Okay. Don't try to take fraction over here. You will divide 84 by 5, it will merely come as 16 point something. Again you have to multiply that term and it will come again as 84%. Don't do that. Keep it like this and then use the just formula of percentage purity. Okay. That is the given amount of gram divided by the total into 100. As simple as that. Let's move on to the next question, students. Here, see this question. Here it is given that what is the mole fraction? Now, what is the mole fraction of solute in 1 molar aqueous solution? In 1 molar aqueous solution. Okay, fine. Just now I have told that there is a formula. Molality equal to mole fraction of solute by mole fraction of solvent into 1000 divided by molar mass of solvent, right? So, molarity is given as 1. Let us take mole fraction of solute as x. Obviously, mole fraction of solvent then will be 1 minus x, because we all know that summation of the mole fraction is always 1. And as here aqueous solution is given, so obviously solution will take it as water. What is the molar mass of solvent water? That is 18. Now, if we solve it from here, it will come 1000x will be equal to 18 minus 18x, like this. So, from here 1018x will be equal to 18. So, x will be equal to how much? 18 by 1018. It will merely come as 0.0177. 0177. This option will be the correct option. Is it okay? So let's move on to the next question, dear students. See, this is a question of limiting reagent, I guess. Suppose here it is given that magnesium is there, fine, and what is there? Oxygen is there, and what is being produced? MgO is being produced. Obviously, we have to balance the reaction. It will be 2 Mg plus O2 equal to 2 MgO, right? Okay, fine. Now, what is given out? Magnesium 1 gram. 1 gram. We have to convert it into mole first. Magnesium means 24, so it will be 1 by 24 mole. 1 by 24 mole. And what is given out? Oxygen? It is given as 0.56 gram. So it will be 0.56 divided by 32, right? Okay, fine. Now 0.56 divided by 32. 0.56 divided by 32 is merely equal to 56 by 3200, like this. Okay. And now if I calculate which one is the LR, that is limiting reagent, what we'll see here, what we'll do, we'll just say that 1 by 24 divided by 2. Always divide the number of moles by stoichiometric coefficient. Now if I divide it by 2, it will be 1 by 48, and it will be how much? If well divided by 1, it will remain same, right? Okay. So 56 by 3200, and in one side there is 1 by how much? 48, right? So there are two things. Now if I divide, suppose 1 by 48, 1 divided by 48, it will come near about 0.020. I am writing it in a separate place, 0.020. And suppose if I divide 56 by 56 divided by 3200, it will come nearly as 0.017, 0.017. So you can definitely see which one is lesser. Lesser is ultimately this one. So this one is our LR, right? And this one is our ER, that means excess reagent. So what we have to find it out, which reactant is left in excess? First question is solved, that is magnesium. And how much? Now comes the main thing, that is how much, and we have to calculate it in gram. Now first calculate it in mole, then we will go to calculate it in gram. Now how much? Suppose how much reacted, let's just find out first. How much has reacted? How to find it out? That what is the stoichiometric coefficient? It will be basically 2 divided by 1 into 56 by 3200, because whichever species you are finding out that how much it is reacted, what you will do, you will just take the stoichiometric coefficient of that species divided by stoichiometric coefficient of LR into number of moles of LR. So it is coming near about this much, right? Okay. So if this much has reacted, so how much is left? We have to find it out. Achha, this is in mole. So what I will do now, 1 by 24 was the initial moles. 1 by 24 was the initial moles, right? So we'll say that 1 by 24 minus, it will be 2 into 56. That means it is 112 divided by 3200, like this. Okay, fine. Now suppose 24 into 3200, this is the LCM, and over here it will be 3200 minus, over here it will be 112 into 24. 112 24 means 48, 8, 4, 24 ones are 24 plus 4, 28, 2, 24 ones are 24 plus 2, 26. That means 2688. 2688. So 3200 minus 2688. Nearly it will come as 3200, 2688. It will come as 21512. So it will be 512 by 24 into 3200, right? Is it okay? Fine. And we all know 512 is a very familiar compound, because what I think is that 64 into 8, it becomes 512, right? So here now if I say that, and 64 into 8, I write it like this in case of 512, that it is 64 into 8, right? Okay, fine. Now what I will do now, 3200, if I cut it by 32, 100, it will be 2, right? Now if I cut it by 2 and 24, it will be 12. Now if I cut it by 4, it will be 3 and it will be ultimately 2. So it is coming as 2 by 300. So 2 by 300 is the amount. 2 by 300 mole is the amount it is left. But we have to find it out in gram. So how to find it out in gram? Given mass will be how much? Given mass will be number of moles, whatever we have find it out, into its molar mass. What is the molar mass? Molar mass of magnesium, that is 24. So ultimately it is coming how much? 48 by 300, right? Okay. So 48 by 300. And if we just calculate it, that how much it is coming, 48 divided by 300, it will come nearly as 0.16. So ultimately which option is the correct option? Option 1 is the correct option, that is mg and 0.16 gram. Is it okay, students? Let's move on to the next question then. Now see, equivalent weight of a bivalent metal is given. Okay. Now we must know that equivalent weight is equal to atomic weight into its valency, right? So obviously if equivalent weight is given over here, then what will be the atomic weight of the metal? Atomic weight of metal will be 37.2 into 2, that is near about 74.4. Now what can be the formula of the chloride? Here we have to find out what is the formula weight of the chloride. Formula of the chloride will be ultimately, as the metal is bivalent, it will be MCl2. So obviously it will be ultimately atomic weight of the metal, we have already find it out. So it will be 74.4 plus 2 into 35.5, it will be 145.4. Sometimes very easy questions we miss out and we try to find many formulas that how to solve these questions, but definitely you must take a look that these are very easy questions, and ultimately in NEET there will be 40% of these types of questions where ultimately students will make any kind of silly, there is a probability of students making silly mistake. So to avoid silly mistake, please be aware that after doing all the sums you must have 30 minutes remaining so that you can once revise at least. Okay, let's move on to next question. Achha, this is a very important type of question. These questions normally come, a sample of H2SO4 density is given, is labeled as 86% by weight. So obviously weight of H2SO4 equal to what I can predict as 86 gram, and weight of solution what I can write as 100 gram. Now what will be the volume of solution? Volume of solution, first of all we have to find out what? We have to find out that what volume of acid is to be used to make 1 liter of 0.2 molar H2SO4, right? Achha, now how to find out the volume? Density is to given obviously. So volume of the solution will be, it will be 100 given mass divided by, that is density 1.787, this much ml. Okay. So now if I convert this ml into liter, what should I do? 100 by 1.787 into 1000. This will convert into liter, right? Okay. Now what can be the molarity of H2SO4 then? Molarity means number of moles of solute. Number of moles of solute means what? Given mass by molar mass, that is 86 by 98, right? And in the denominator it will be volume of solution in liter. So what is the volume of solution in liter? 100 by this thing, so it will be 100 and by 1.787 into 1000, right? So this is the molarity of the solution. Now what I can say from here, if I calculate this, it will merely come as 15.6 something. Now we all know that there is a famous formula, that is N1V1 equal to N2V2, right? Now what is given about, what is the, by M1V1 is equal to M2V2, what is given the molarity? 15.6 into, we don't know the volume of the acid, that has to be added, equal to 1000. The volume has been given as 1 liter into how many, how much molarity is given? Molarity is given as 0.2. Okay, fine. So if I now calculate from here, it will come as near about 12.75 something. So what is the correct answer? It will be option 3, that is 12.75. Is it okay, dear students? So here we complete. I think the main area where you have to look in case of mole 1, you have to look over stoichiometry part, you have to look over limiting reagent part, you must look over the molarity, normality, equivalent weight, all these things, okay. And basically the number of equivalents part come in redox side, okay. We always equal the number of equivalents of two species which are reacting in the redox side, and it may not be reacting, it may be one will be present in reactant, one will be present in product. Actually the information which is given about any two species, we try to equalize their number of equivalents, okay. So let's come to the redox reactions chapter, that is mole concept 2 now. Now for mole concept 2, see the first question that is given over here, that is the correct order of nitrogen compounds in decreasing oxidation state. That means we have to find out the oxidation state of each and every one from this compound first of all, right? After finding out the oxidation number, then we will manage it in decreasing order, okay, fine. So what you can see, students, in option number 1, suppose if I do over here in HNO3, nitrogen is +5, okay, we all know. In NO, oxygen is -2, N will be +2. In N2 it is 0. In NH4Cl, Cl is -1, and in front of nitrogen, hydrogen will get positive. So it is -1, it is basically +4. So obviously it must be -3. It must be -3. So here we can definitely take a look that it is in decreasing order. That is 5, 2, 0, -3. We don't need to solve any of the other things, okay. So the first option will be the correct option. If you want to check, you can check it, but the same compounds are given in a different pattern, so obviously they will be in decreasing order. The correct decreasing order will be this one, okay. Let's move on to question number 2. In question number 2, a balancing has been given. In acidic medium, we have to do the balancing and write the exact coefficients of these things, okay, fine. Now suppose MnO4 minus, MnO4 minus is going to Mn plus 2. Now the atom which is getting change in oxidation state, it is so balanced, obviously we can see. In the left hand side there are 4 oxygen atoms. First step is to add 4 oxygen atoms by adding 4 water molecules on the other side. After adding water molecules, what we will do? We will add same amount of H plus what we are getting from water. Is it okay? Fine. Now we have to balance the charge finally. See, in the left hand side the charge is +8 because it is 8 plus 1, and over here it is -1. So ultimately +8 -1 means here net charge is +7, and over here net charge is how much? +2. So obviously if I add 5 electrons over here, it will get balanced. Now coming to the second equation, that is C2O4 2 minus, it goes to where? CO2, right? Now CO2 is neutral, what we can see over here. First of all, the atom which is getting change in oxidation state, that is carbon. Here carbon is say +3 each carbon, and here carbon is +4. So obviously carbon is changing in oxidation state. So here how many carbons are there? 2, but here it is 1. So first we should write 2 over here, okay. So now the oxygen is also balanced, no need to worry about it, right? So ultimately net charge on left hand side here is -2, right? Okay. So what I can do, if I add ultimately 2 electrons over here, then what will happen? Ultimately this side will also get -2. So now the charge will get ultimately balanced. Is it okay? Fine. Now here it is 2 electrons, here it is 5 electrons. So obviously this will be multiplied by 2 and this will be multiplied by 5, then only they will get cut off, okay. Now if it multiplies by 2, MnO4 minus will be 2, stoichiometric coefficient. H plus will get 16H plus, and C2O4 2 minus, it is multiplying by 5, so it will get 5 C2O4 2 minus. So our question has been already solved. MnO4 minus is 2, C2O4 2 minus is 5, and H plus is 16. Only this option is the correct option. No need to solve the entire problem to get into this. Okay. Thank you, students. Moving on to the next problem. the oxidation state of A, B and C in a compound are +2, +5 and -2 respectively. The compound is. Now we all know ultimately the net charge should be 0. So this is a question which is nothing but it is a time consuming question where we just have to check putting the values of their oxidation state, that in which case it is coming as 0 and which case it is not. Okay. So let us choose any one of them. Suppose if I choose A2BC whole twice, A is how much? A is +2, so it is +2 into 2, that is +4. B is how much? B is +5, +5 into 2, that means +10, and it is -2 into 2, that is -4. So ultimately it is getting +10 and it is getting -4. +10 -4 means how much? +6. And A is how much? +2 into 2 means +4. So it is not coming as 0. Let's choose option number 3 now. In option number 3 it will be 3 into +2, right? Now it will be +5 into 2, right? Plus it will be -2 into 4, এটা তো আছেই, তার -2 into 4 into -2 into 4 into it will be twice. -2 into 4 it will be twice. So ultimately 3 into +2 is +6. Here it is how much? +10. And here it is how much? 4 to the 8 to the 16, but entire thing will be minus. So obviously we can see here that it is getting as 0. So option 3 is our correct option, right? Okay. Let's move on to the next question. Which of the following is not an example of disproportionation reaction? See, we can check it out from here. Very easy. In case of the second reaction, Cl2 plus OH minus. Now in Cl2, Cl to is 0. And in ClO minus, Cl is +1 and Cl it is obviously -1. So it is getting oxidized and reduced at the same time. So obviously it is not. It is an example of disproportionation reaction. Now let us come to Cu2O. In Cu2O, each Cu is +1, right? Over here Cu is 0 and it is +2. So at first it is decreasing from +1 to 0 reduction and from +1 to +2 oxidation. So these are also example of disproportionation reaction. And in the last one, HCuCl2, Cu is +1. Over here again Cu is 0 and over here it is +2. So these also an example of disproportionation reaction. Only left with one option, that is this one. This is not an example of disproportionation reaction. Is it okay? Fine. Let's move on to the next question. In the following reaction, the equivalent weight of AS2S3 is related to the molecular weight M by. It is a very easy question because in AS2S3 just we have to calculate the n factor, then only we can calculate the equivalent weight, right? In AS2S3 just now we did similar type of a question that S is to -2, each S is -2, so net will be -6. It must be +6, so each AS will be +3. And here in ASO4 3 minus, if I calculate, AS will be how much? AS will be, suppose if I pick it up as x minus 8 equal to -3, so ultimately AS will be +5, right? Is it okay? Fine. Now what should be the n factor of AS2S3? First of all we need to know that. Let us check the sulfur. Sulfur here it is -2. Here in SO4 2 minus sulfur is how much? +6. So ultimately what is the AS2S3 n factor? Each AS goes from +3 to +5. That means 2 unit change. So for 2 AS atoms 4 unit change, and for sulfur each S goes to from -2 to +6. That means 8 unit change. So ultimately net 24 unit change. And here it will be 4 unit change. That means n factor will be ultimately 28, 24 plus 4. So equivalent weight is equal to molecular weight capital M divided by 28. Is it okay? Fine. I don't think there is any problem regarding this. Let's move on to the next question. What volume of K2Cr2O7 solution is required to oxidize this much gram of H2S in acidic medium? Now as soon as you see K2Cr2O7 is there, whichever medium it is saying, always remember one thing, that ultimately it will go to Cr+3. Now in H2S, S is in minus 2, it will oxidize. Oxidize means S from minus 2 it can go to only one place, that is S0. So obviously N factor in K2Cr2O7 each Cr is how much? Plus 6. So what is the net change in Cr atom? For 1 chromium atom 3 change, for 2 chromium atom 6 change. And for sulfur, so for K2Cr2O7 N factor equal to 6, and for H2S what is the N factor? N factor is from minus 2 to 0, there is only 2. Is it okay? Fine. Now we know the formula that number of equivalents of this will be equal to number of equivalents of this basically. So what should we do now? What is the number of equivalents of K2Cr2O7? How to find out? Normality into volume of solution. We don't know the volume of solution. So what is the normality given? Normality given as 2 into, we don't know the volume of, but this volume will come in ml, right? Equal to, here also normality into, now we don't know the normality, we know the gram. Now we also know there is another formula for number of equivalents, that is what? Number of millimoles into N factor. So what is the number of moles? 0.81 divided by how much? 34. This is the number of moles into 1000 becomes millimole, into 2 becomes ultimately number of equivalents. So from here volume in ml we can easily predict, if we calculate all this it will come near about 23.8 ml. Okay, so this option is the correct option. Is it okay, dear students? So here we complete our first part, that is atomic structure, mole concept 1 and mole concept 2. In the next class, that is part 2 of chemistry, we will discuss about periodic table and chemical bonding. Hope to see you soon. Thank you all.